Hello students, welcome to ePhysics. Students, in this video we will be discussing the NCERT solutions of class 11th physics part 2, and the chapter's name is waves. Okay, we will be discussing in parts. Half questions will be discussed today and the other questions will be discussed later on. So let's start with the first question. The first question is on the screen, students. A string of mass 2.50 kg, that is mass have been given. Let us write it first. Capital M, mass is given, that is 2.50 kg, is under a tension of 200 Newton. Okay, the tension on the screen on the string is 200 Newton. The length of the stretched string is also given. The length is equals to 20.0 meter. And next part is, if the transverse jerk is struck at one end of the string, it means we are having a disturbance. Okay, disturbance, that is a wave. Okay, so how long does the disturbance take to reach if the disturbance has been created at one end, then what time it is taking to reach the other end? So students, we have a formula of time, that time is equals to length or the distance traveled divided upon speed. Okay, distance traveled divided upon speed. So here we can find, if we have the length, that is 20.0 meter. Okay, 20.0. If we get the speed over here, that is the velocity of the transfer of the energy from one point to the other point, we will be able to find the time taken, okay, to reach the disturbance from the beginning, the start point, to the end point. Okay, so how will we find it? We know a formula, students, that tension is equals to root under, sorry, my mistake, that is velocity is equals to root under tension upon small m, where this small m is equals to mass per unit length. Okay, the mass is already given, that is 2.50 divided by the length is 20. Okay, the mass per unit length will be somewhere around 0.125 kg per meter. Okay, so kg per meter, and tension has already been given. So velocity will be equal to root under tension is 200 Newton divided by the mass per unit length is 0.125 kg per meter. When we solve it, we get the velocity is equals to 40 meter per second. Now since we have the velocity, we will put the value of velocity in this equation and we will be able to find the time taken. So the time taken will be equal to distance upon speed, or velocity. In this case we are taking velocity. Distance is 20 meter divided by velocity is 40 meter per second. So 20 upon 40, that is 0.5 seconds. Okay, so that from the energy, the time taken by the energy to reach from the one point to the end point is equals to 0.5 seconds. So this is a easy question, the first question of the day. So now let's move to the next question now. The second question is on the screen, students. A stone is dropped from top of a tower of height 300 meter. So let us consider we have a tower whose length is 300 meters. The stone is dropped from here. Whenever the thing or the object is being dropped from any height, its initial velocity is 0 meter per second. We have to remember this, we have to keep this in mind. And it splashes into a water of a pond near the base of the tower. The pond is somewhere near the base when the splash is heard at the top. So the question is asked, time taken by the splash sound from here to reach the top. So let us consider the time taken by the object to reach the pond, reach the water body, is t1, okay, and the time taken by the sound to reach the top is equals to t2. So the total time will be equal to the total time will be equal to t1 plus t2. So let's find t1 and t2, and the speed of the sound in air has been given, that is 340 meter per second, and the g ka value is 9.8 meter per second square. So let's solve it. Okay, now we have a equation that from the Newton's second law or second equation of motion, we have that s is equals to ut plus half a t square. Okay, so here s is equals to the height of the tower, u t1, because we are talking when the object is falling downwards. Okay, when the object is falling downwards, then the value of the g, when the object is falling from any height, the value of g will be taken positive. So this is g t 1 ka whole square. So if we take h is equals to uh, the height of the tower is given, that is 300 meter, u ka value is 0 multiplied by t1 plus 1 by 2, g ka value is 9.8 multiplied by t ka square. So now next thing is 300, okay, this is multiplied by 2 divided by 9.8 is equals to t ka square. So finally t will be equal to, this is t1 of course, yes, t1 will be equal to root under 300 multiplied by 2 divided by 9.8 seconds. Okay, now when we solve it, we get a value somewhere around 7.82 seconds. So this is the value of t1. So to find the value of t2, t2 is the time taken by the sound after it splashed on the water body. The sound reaches the top. Reaches the top means that is again it travels 300 meters. Okay, and this is what we have turned it as t2. Okay, so now let's find t2. For finding t2 students, we have a simple formula, that is distance traveled. We have used this formula in our childhood, of course. Distance traveled upon speed. Here we are taking velocity. So distance traveled will be 300 meters, and the velocity it has been given, that is 340 meter per second, itna seconds. So finally we get it as 0.88 seconds. So the total time will be equal to t1 plus t2, which is equals to 7.82 plus 0.88 seconds. So after calculating it, we get the value somewhere around 8.7 seconds. So this is how we can solve the questions. Okay, so now let's move to the next question. The third question is in the screen, students. We have a steel wire whose length is 12 meter. Okay, the length is given, that is 12.0 meters, and the mass is equals to 2.10 kg, and we are supposed to be finding, the question asks what should be the tension in the wire. Tension means capital T, we have to find it, wire, so that the speed of the transverse wave on the wire is equals to 343 meter per second at 20 degrees Celsius. Okay, now we have the formula that V is equals to root under T, that is tension, divided by mass per unit length. So the mass per unit length will be equal to the total mass, that is 2.10 kg divided by 2.10 kg divided by the length is given, that is 12. Okay, so 12 meter, so itna will be kg per meter. This is the unit of the mass per unit length. When we solve it, we get the value somewhere around 0.175 kg meter per second. Okay, now we have got the value of value of m. We have to find the value of T. When we square both sides, we get V square is equals to T upon M, that is mass per unit length. Therefore, tension will be equal to V square multiplied by mass per unit length. V square, the value of V has been given, that is 343 meter per second. So 343 into 343 because of the square, and the mass per unit length is 0.175. okay, 0.175 Newton, kg per meter. Now the tension, unit of tension is meter, of course. Now the value after calculating this is somewhere around 2.06 into 10 to the power 4 Newton. So this is how we find the tension of the wire. We have the formula. We have discussed this formula in equation in first question as well of this video only. So now let's move to the next question. The next question is on the screen, students. Using the formula root under gamma P for pressure divided by density. So using this formula, explain why the speed of the sound in air does not depend upon the pressure, and it increases with the temperature and humidity, and increases with humidity. Okay, we have to explain all this. So let's start with the first part. Okay, so solution, that is the first part, that it says that velocity is equals to root under gamma P for pressure divided by density. Why does not depend upon the pressure? We have to solve it. Okay, now we know that density is equals to mass per unit volume. Now if we put this in this equation, we get V is equals to, okay, V is equals to root under gamma P upon mass per unit volume. And we know that, students, okay, for ideal gas equation, in the case of ideal gas equation, PV is equals to RT. If we put T as constant, we know that R is equals to Rydberg constant. It is already constant. Therefore, PV will also be equal to constant. Okay, so from this equation we can see gamma is already a constant, mass is already a constant. Okay, and we have just found that PV is also constant. Therefore, under the value under root, that is gamma PV upon M is constant. Therefore, V will also be equal to constant. So we can simply say that the speed of the sound in air does not depend on pressure at any constant temperature. Okay, so we can write it as the speed of sound in air does not depend on pressure at any constant temperature. Okay, at any constant temperature, the speed of sound in air does not depend upon the pressure. So this is what we are supposed to be proving, and we have proved it over here. So now next move to the second part. Okay, now the second part says that it increases with temperature and humidity. Okay, now it increases with temperature and humidity. Now we have the formula that V is equals to root under gamma P upon density. Okay, and from ideal gas equation we have been knowing that PV is equals to RT. So we can write it as P is equals to RT upon V. If we put the equation over here, so we get it as root under gamma RT upon density into volume. So we know that density into volume is equals to mass, that is gamma RT upon mass, and we know that gamma is constant, R is constant, mass is constant. Therefore this depends upon temperature. Okay, so this is how we solve it. Okay, now the second part of the question is also done. So that's it with the video, students. We have discussed a few questions over here. So I hope you have understood all the things properly. You can see the video, you can pause the video, you can repeat it until you get it. Okay, and the PDF, the annotated PDF will be provided in the Telegram link, whose link will be given in the pinned comment. So thank you very much for watching the video.